Hello, welcome to the first, this is I guess our third day, but today we're going to talk about in general probability, which we worked on with Venn diagrams and tree diagrams. But today we're going to talk about probability as well as conditional probability. So just a quick review. Here, what probability is, and you guys know this is our desired outcomes over our total outcomes. And this is going to really help to refer back to this when we start talking about conditional probability. So this one, the first we're going to start out are ones that you guys are like, yep, that totally makes sense. We're going to talk about a couple different ways to look at it. And then we're going to take a look at some with conditional probability. So the first one, there's a spinner. Numbered 1 through 15. And you want to know what is the probability that it is a multiple of 3 and 5. So again, we can first list out our desired outcome. So we have, or excuse me, our total possible outcomes, the total. So we could get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. But we want, and again, I'll use that notation, a probability of a multiple of 3 and 5. So remembering that upside down is and. So if we look through this list here, the only one that's a multiple of 3 and 5 is 15. So our probability is 1 out of 15. Where if I would have said probability of 3 or 5, so remembering that U is or, if I start to take a look at those 3 or 5, we add in a whole bunch more. So 3 or 5, and we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So our total would be 7 out of 15. And now what if I said that it is the probability of a multiple of, let's say I said a multiple of 16. And again, all of these I should have put multiple on. I apologize for not. But a multiple of 16, there aren't any, so it'd be 0 out of 15 or 0. So the next one we're going to take a look at, and again, we're going to take a look at maybe 4 problems today. Let's say in a class of 29 students, 5 play basketball, 16 play baseball, and 10 play neither. And you want to find the probability, sorry, I'm abbreviating here, the probability that they play both. So we're going to take a look at 2 different ways. One is the way we looked at this yesterday, or 2 days ago was it now, with Venn diagrams. So you could draw your Venn diagram, and there's 29 students, and you know that 10 play neither. So 10 is outside, and then you could say, well, 29 minus 10, so we have to have 19 on the inside. But if we total our basketballs here, we have 5 and 16. So there's a total of 21 on the inside. So we need 21 on the inside. So we must know, well, actually, how many do we need on the inside? We need 19 on the inside. Okay, sorry. But we know that in our circle there's 21. So if we do 21 minus 19, there's an overlap of 2 in here. And I'll say this is basket and this is baseball. So that means there has to be 3 right here and 14. Sorry, I did not explain that very well. But a total of 19 on the inside circle, but 15 and 16 makes 21. So there has to be that 2 that overlaps. So if we want the probability that they play both, it would be 2 out of 29. Another way we're going to look at this one today, and we're going to take a look at some more of these tables here, is a nice way to look at ones is to make some tables. So all of the possibilities, you could play basketball or no basketball. You could play baseball or you could play no baseball. And so the number that we know that 10 play neither. So we know that 10 needed to go in this box. Now on the outside of all these, we can write our totals. So we know that 16 play baseball. So I'm going to put this row has to equal 16. And we know that 5 play basketball. So this row has to be 5. But we know our total number of students has to equal 29. So each of these on the outside, our totals has to be 29. So this column would have to be 24, and this column would have to be 13. Because again, we have 29 students. So our baseball and no baseball has to be 29, plus our basketball and no basketball has to be 29. And now it's just like a little puzzle. Well, if no baseball totals 13, this has to be 3. If the first column is 5, this has to be 2. And our first row is 16, so this has to be 14. And again, we get that same 2 this way. So let's take a look at another table here. So let's say I was to make a table, and we're going to talk about dogs and cats. So let's say if we did cat, no cat, and I'm just going to give you all the information for your dog, no dog. And I'm going to type in all these numbers. So let's say we have 6, 9, 2, 11. So if we total this first row is 8. This first row is 20. This first column is 15. This is 13. So our total here, because our outside totals, is 28 on each of them. And this is where we're going to start taking a look at this conditional probability. Well, let's take a look at a couple of them here. So what's the probability that you have a dog? Well, the probability of a dog, how many have a dog in that first row is 8, so it would be 8 out of 28. Now, what if I said, what is the probability that you have a dog if you have a cat? So this one is what's called conditional probability. We put a condition on. We want to know that you have a dog if you have a cat. So this is our total outcomes. We want to know that you have a cat. So how many have a cat is, let's see, our cat column is 15. And of those 15, so we're only looking at our condition that you have a cat. How many of those have a dog is 6. So it would be 6 out of our 15 here. So let's take a look at one more of these tables and see if we can figure out the condition, all these conditional statements. So we're going to say that you complete homework or no homework completed. And then our other table, on our other side, we're going to say that you passed the test or no pass. Oops, I don't know what happened there. So let's say our numbers here are 15, 7, 2, and 3. So the first thing we do, let's do some more totals here. So 15 plus 2 is 17. 7 plus 3 is 10. 15 plus 7, oh my gosh, I'm sorry guys, is 22. 22. 2 plus 3 is 5. So our grand total, when we look out here, our grand total, 22 plus 5, is 27. And the same thing for 17 and 10. So what I'm going to ask you guys is, what is the probability that a student who completed the homework passed the test? So again, we're not looking at that 28. What is our desired outcome? But they passed the test, but our total outcomes is the probability that a student completed the homework. So if we look, we're just looking at probability that they completed the homework. That's our total outcome. So if we're looking at that row, so of those 22, how many passed the test? Is that 15? Notation-wise, sometimes you'd see this as the probability that completed homework given that they passed. Oops, I did that backwards. We want the probability that a student passed the test given that they completed the homework. So when you look at that way, it's kind of like a fraction. We're just looking at the completed homework, which is our 22, and you want to know of those who passed the test.